Greetings. Welcome to Introduction to SQL for Excel Users, Part 3, Basic Filters. I am your instructor, Dave Langer. Let's go ahead and get started. So first we have some housekeeping items that I like to cover in each video in this tutorial series. First is how to get the software. So if you head over to the YouTube channel, my YouTube channel, you'll see that there are these two videos. One is for SQL Server on Windows, so that allows you to install SQL Server for free on your laptop or on your desktop computer. Or if you happen to want to use the cloud, or if you're using a Mac, let's say, you can take a look at this video, and this will tell you how to get set up for free with everything that you need for this tutorial in Microsoft's cloud, which is known as Azure. So between these two, you should be covered, whether you want to run SQL Server locally, or if you want to use SQL Server in the cloud. Next up, all the files for this tutorial are found on GitHub. github.com/davondata/SQL4Excel users. All the Excel files, all of the SQL files will be uploaded to this GitHub. It's public, you can grab them at any point in time. The subject of this video is filtering. Now, this is something that you do all the time in Excel, and you might not even think twice about it, and that's only natural. However, as you might imagine, just as filtering is extremely common in Excel, it's also extremely common in SQL. When you write queries to run against the database, you want to filter down all of the possible data in the database to just those records, just that data that you want. So filtering is extremely important, which is why it's one of the first things that I'll be covering in the series. So you can think of filtering as coming in four distinct flavors. One, using a single column using a single condition. Two, a single column using multiple conditions. Three, multiple columns using a single condition for each column. Or four, multiple columns using any number of conditions for each column. And you could make an argument that really 3 and 4 are basically the same thing. Now, as I said, you probably filter in Excel all the time without really thinking about it. So I'm going to go over this in detail. And the reason for that is quite simple. We need to establish a conceptual framework of how we think about data and filtering. And we'll use Excel, as always in this series, as the frame of reference. But we'll do it in such a way that it maps conceptually very well to the world of SQL. So if it seems like I'm going very slowly and I'm doing something that's extremely tedious, then I apologize, but it's necessary for making sure the maximum amount of understanding for the maximum number of people happens. Okay, so what we have here, as you can see, is SQL for Excel Users Part 3, which you can get from the GitHub, and there'll be a link in the video description to the GitHub. And what we have here is a table, not surprisingly, and it's the call center table from the AdventureWorks database, the sample database that you've downloaded or you've set up in the cloud. And what we can do here is we can say, okay, let's take a look at these filtering conditions one at a time. So the very simplest one is I want a single column and I want a single condition for my filter. And in Excel, this is exceedingly easy. So let's say, for example, that I want to filter on the shift column, right here, column D in this table. So all I have to do in Excel, it's handy dandy, is just click on this and say I only want PM1. I only want to filter on a single condition. So if I do this, voila, right? I only get 30 out of 120 records here. And you can see that I get just the records in the table, in the Excel table, that have a value of PM1 for the shift column. Okay. Now, like I said, exceedingly simple. Wow, Dave, what's the big deal? Okay. So here's what I want you to think about. While this is conceptually simple, what I want you to think about is from a different perspective what's really going on here. So if you imagine Excel as a series of containers, if you think of like a Russian doll, right, where you open up a big doll and inside that doll is a smaller doll, and you open up that doll and there's a smaller doll, and so on and so forth until you get all the way to the bottom. That's a container hierarchy, right? The larger dolls contain the smaller dolls, and that goes recursively down until you get to the last smallest doll. That's a very powerful way to think about Excel as well. Excel is arguably a container hierarchy. At the highest level, you have the file itself, the workbook. This is the largest container of all. A workbook contains one or more worksheets. And you can see here we have the single column, single condition worksheet is contained within the workbook. Okay. Now, within this worksheet, you can also have tables contained. Now, typically you only have one table per worksheet, but you don't have to. You can actually put multiple tables inside of one worksheet. So now we have 3 levels of containment. We have at the highest level, the workbook itself, the Excel file itself. Then we have a worksheet. Then we have a table. And then lastly, you can make an argument that we have a column. So a column, in this case, the shift column. So that allows us to create, logically, a container hierarchy. Now, we can think of this in terms of text. It's actually a little bit easier to think of it this way. So if I bring up Notepad here real quick, you can think of Excel as a hierarchy like this. So first we have the workbook, right? SQL for Excel users part 3.xlsx. That's the outermost container, the biggest container. And then within that, we have a worksheet, which we call here single column, single condition. And then within that worksheet, we have the call center table. And then lastly, we have the shift column itself. Now, this is extremely useful because that means logically, we can think of our filter in terms of a containment hierarchy such as this. So if we just scroll down here, I can show you what I'm talking about. So this is a logical way to think about the filter that we just implemented. I want all the rows of the call center table where the shift column is equal to the value of PM1 here. Oh, and that call center table just happens to be within this worksheet, which just happens to be within this workbook. So you'll notice that that's almost like an address. So like, for example, in the United States, maybe you live at 123 East Elm Street in Los Angeles, California, and you have some sort of zip code 95 something or other, probably something like that. Notice that even that is a hierarchical container. Right? You live in the United States, then you live in the state of California, then you live in Los Angeles, then you live in this specific area of Los Angeles, and then you live on this street at this particular address. Same idea. Same idea. This hierarchy allows us to create filters. This is extremely useful. Now, why this is extremely useful is that you can think of this as being mapped to SQL. And here's how we could do that. So using the same idea, the same conceptual idea, we can generate 100% totally legit SQL. Now notice the concept is exactly the same. I'll just expand this a little bit so we can see both of these at the same time. Okay, so the outermost container in this case was the Excel workbook. Down here in SQL world, the outermost container is the database, right? AdventureWorks DW 2017 is the name of the database that we are using for this tutorial series. And then next up, you have what's known, next up you have the worksheet here in the Excel world, and that maps conceptually to what is known in SQL Server world as a schema. Don't need to worry about that right now. Just think of it as a container. Just like a worksheet is a container inside of an Excel workbook, a schema is a container inside of a database. This schema just happens to be called DBO, which stands for Database Owner, in case you were curious. And the next up, of course, you have the table in the Excel workbook, which is call center in this case. And down here, it's fact call center. As I mentioned in the last video, the tables in the database have a naming convention, dim and fact, though we don't really care for our purposes what that differentiates, how that differentiates the table. So this is just the call center table. And then lastly, we have the shift column, which maps conceptually right here. And then lastly, the filter, which says, look, I only want values out of the fact call center table where the shift column is equal to PM1. Now this whole thing right here is 100% legit SQL. It is 100% legit SQL. This is what's known as a predicate. A predicate. You use these in your SQL to filter. And conceptually, they work exactly like they do in Excel. Even though in Excel we don't write this all out, we don't code it by hand, conceptually that's what we're doing when we use the UI. When we use the filter dialogues in Excel, this is basically what we're doing. We're building up a filter. Okay. Now, what often happens is you don't do the full hierarchy in SQL because it's just a lot of typing. And also you typically don't do the square brackets. You can, you absolutely can. It's totally fine. It's legit SQL, but most of the time you don't. People kind of find it a little bit off-putting from a stylistic perspective. So what you see here is the most common form of a predicate in SQL. So this is literally the filter. And notice once again, and I can't stress this enough, that conceptually it's exactly what you're doing in Excel using the graphical tools, the dialogues, the clicking, the clicking and the drop downs and the checkboxes and all that kind of stuff. In SQL, you just type it out by hand, but conceptually it's exactly the same thing. Okay, let's move on to a single column using multiple conditions. So we can just flip over to this worksheet right here. And we can say, for the sake of argument, that I want to only have the rows in the table, in the call center table in this worksheet, that have values of PM1 or PM2 for the shift column. And that's pretty easy. And I just open up the filter. Let's just go ahead and pretend like I hadn't had this before. So I open up the worksheet. Here's my table of all the data. And I say, okay, I don't want all the rows. I just want to filter down. So I just want PM1 and PM2. Boom. Okay, once again, conceptually, not difficult. But I just want to emphasize this point because it'll be germane to what I'm about ready to say about SQL. What this actually does behind the scenes is create a logical condition. It tells Excel, look, go through this entire table, all the rows in the table, and only show me the rows, only return me back the rows, if you want to think of it that way, where the value of the shift column is PM1 or it is PM2. Okay, PM1 or PM2. That's what this is implicitly doing. Okay, so we click OK and we say, well, there you go. We now have our all of our data coming back. Now, once again, we can think of that predicate in terms of, or this filter in terms of text. So we can see here that this is the conceptual way we can think of it. Fact call center dot shift, right? So that's the table, and the column equals PM1 or fact call center dot shift equals PM2, right? This is 100% legit SQL once again, right? Because we can see that right up here that this was the legit SQL for a single column, single condition. Then this obviously should be legit SQL for a single column, multiple condition. And notice that the magic is this thing right here. We literally type out the word or in SQL. Now notice that it's implicit in Excel, right? It's implicit here. PM1 or PM2, those are the only rows that you should show me, Excel. It's implicit. Here in SQL, it has to be explicit. That's how we do things, right? So it's a little bit more work because you're typing these things out, right? You're literally going to be in SSMS, SQL Server Management Studio, and type out fact call center dot shift equals PM1 or fact call center dot shift equals PM2. That's literally how you write your predicates. That's literally how you write your filters in SQL. But once again, notice that conceptually, it maps exactly to what's going on in Excel. You might not have thought about it in that way, but that's the way it is, because when you use these graphical tools, you're essentially behind the scenes just constructing these types of predicates for the filters. Okay, what I'm going to do is I'm going to go ahead and go over to this worksheet now, which is the multiple column and n number of conditions, right? So any number of conditions on multiple columns. Okay, so let's say for the sake of argument, what we want to do is we want to filter on whether or not shift is PM1 or PM2, and if the number of level 2 operators is less than or equal to 10. So how you do that is pretty simple in Excel. One way to do it is you just go here and you uncheck everything and you say, I just want all the rows in the table where the shift column is equal to PM1 or it's equal to PM2. And then you can go over here to the level 2 operators and you say, look, I want only those rows where the shifts are PM1 or PM2 and the count of the level 2 operators is less than or equal to 10. So the easiest way to do that is to go down to the number filters and you can say less than or equal to, and you can just put in 10. Now notice this though, this is very interesting. Notice that when you work with just the out-of-the-box column filters in Excel, you don't get the logical aspects that you see here. You literally have ands and ors. So once again, this is why Excel is such a great vehicle for you to learn SQL, because all the things that are in SQL, or I shouldn't say not all of them, but a lot of the things that are in SQL are also in Excel. And as an analytics professional, querying a database and using data in a database, the mappings are very, very profound. Just about everything that you do in Excel exists in some form in SQL. And all you just have to do is just learn the conceptual mapping from how you do in Excel to how you do in SQL. And here's one example of that. So notice here we're just going to say, look, show rows where level 2 operators are less than or equal to 10. And if we do that, it narrows it down to only 36 rows out of 120 right here. So once again, if we think about this conceptually in a textual format, in a text form, we can flip over here to Notepad and scroll down, and you can see here how this manifests. We have our original filtering condition right here, right? Is shift equal to PM1 or is shift equal to PM2? But notice what we're doing here. We're saying, look, well, but we've added another condition, right? We want all the rows where shift is equal to PM1 or PM2 and where the level 2 operators are less than or equal to 10. Notice that we didn't have to code that up specifically in Excel, but you can see here implicitly, notice these little icons, I'm sure you're familiar with these, that says that there is a filter being applied to these columns, which says, look, this filter is being applied and this filter is being applied at the same time. So conceptually, this makes sense to you as an Excel user, I would imagine, but it also translates directly to SQL. When you see here, this is the first condition, this is the first filter, which corresponds to what we have on column D, the shift column, and then this corresponds to the filter that we have on level 2 operators, column F here. And notice that since they're applied simultaneously, we're filtering with this criteria and this criteria, and you can see right here, the and. Now you'll notice the parentheses. Strictly speaking, parentheses are only required in certain types of scenarios, and the rules are well defined and they can be quite complex. And if you're interested, you can look up order of precedence for SQL. However, I would advise you not to do that. The easiest thing to do is just say, look, when in doubt, wrap something in a parentheses, because what that does is that tells SQL this is a logical unit. The parenthesis says this is a chunk. I want you to evaluate this chunk, this predicate, this filter chunk by itself. So I want you to say, look, shift is either PM1 or it's PM2. Filter down to just those rows, then say, okay, and further filter with this chunk right here, which is to say, okay, shift has to be PM1 or PM2, and then out of that, only give me the rows where level 2 operators are less than or equal to 10. So that's where we come in. Now, this is 100% legit SQL right here. We're already writing some SQL. Now, it's a snippet. You couldn't actually like run this against the database. You would get an error because the database would say, look, this is not a well-formed query. However, this is a legitimate snippet of SQL. In particular, this is a legitimate snippet of how you would filter on multiple columns with multiple conditions. And as you might imagine, this base pattern just repeats, right? You can create ever more complicated filters in SQL just like you can in Excel. So for example, I could say, oh, and PM1 or PM2 for the shift column filter, less than or equal to 10 for the level 2 operators filter. And also I'm interested in where the calls are, let's say, greater than or equal to 300. There you go. And then how we would do that conceptually is we would just do this. We would just say and I'm just going to go ahead and wrap this around to the next line. You could have typed it all out on one line. And then you just say fact call center dot calls is greater than or equal to 300. And that's basically how you build up a filter, how you build up your collection of predicates in SQL. Notice, and I know I'm beating a dead horse here once again, that it's conceptually exactly the same as you do in Excel. Because now, once again, this filter is being applied to the data, and this filter is being applied to the data, and this filter is being applied to the data. That's it for this episode. Basic filters. Next up, we're going to start getting a little bit more interesting with what we're doing. We're going to start talking about selects, which is the basic form of SQL that you use for querying data from the database. So until next time, I wish you very happy data sleuthing.